Hi, I'm Andy Zhu from Mr. Happ's Period 2 class, and today I'll be explaining how to do 2006 FRQ number 1 on the AP Calculus AP exam. Now here's the given problem statement. Let R be the shaded region bound by the graph of y equals ln x and the line y equals x minus 2 as shown here. Now part A is asking us to find the area of region R. This problem requires the use of a graphing calculator, and Wolfram Alpha will be my graphing calculator, and I will explain how to do it on your own handheld graphing calculator. Now, to find the area of region R, you have to find where the graphs of y equals ln x and the line y equals x minus 2 intersect. You have to do this so you can find the bounds of your integral, and you can just integrate of the top curve minus the bottom curve and just get your answer. Now, to find where these intersect, we have to set these two lines equal to each other. So you get ln x equals x minus 2. Do this on your calculator, in your handheld calculator. You can just find a numSolve button and then plug in the given equation, and you should be able to find a solution. When we plug it into Wolfram Alpha, as shown here, we get the numerical solutions of x equals 0.15859 and x equals 3.14619. Now, make sure these are the proper solutions. What we can do is plot these two curves and make sure that this plot is the same as this plot. In this case, they are. So we know we have the right solutions. Now, to find the area, as previously stated, we just do the top curve minus the bottom curve, and we can take the integral with the bounds. So when we integrate, just from 0.15 to 3.14 of the top curve, ln x, minus the bottom line x minus 2 of dx. And this is pretty simple to do with a graphing calculator. All you have to do is go to your integral button, the definite integral, plug in your bounds, and then plug in ln x minus 2 dx, and you should get the answer. And right here on Wolfram Alpha, we can see the answer is 1.949. Now moving on to part B. We're asked to find the volume of the solid generated when R is rotated about the horizontal line at a y equals -3. Now let's first look at a graph of this. Excuse the bad drawing, but this is what we get. Now, to solve this problem, I'm going to imagine shifting this thing until y equals x minus 3 is the x-axis. So then we would just get something shifted up by 3, and we'd still get the same graph. I know it's kind of hard to visualize, but imagine it like this. So this equals y equals -3, and this graph would be shifted up over here. This is just an easier way to think about it. Now, once you have that, we know how to solve for volume by revolution. It's not that hard. We simply just have to do the top minus the bottom. And as previously, in part A, the top is still ln x. And the bounds are still the same, because we're not shifting it over left or right. So we have to find the integral 0.15 to 3.14 the top, which is ln x. But we have to remember to add 3 because we're shifting the entire graph up. And then we subtract the bottom line, which is again x minus 2. Then we have to add 3 again because we added 3 to the first part. We shifted the entire graph up. And then dx. So this isn't too bad to solve. We can just plug it into our graphing calculator. Again, this is not that bad. Press the integration button, plug in your bounds, and then there should be an ln button, plus 3, and then you can just plug that all in. I'm using Wolfram Alpha, but then we have to remember, we have to multiply this entire thing by pi, right? Because it's, when we do volume, it's r, you have to square these two, right? Because when we do volume, it's pi r squared, and this represents the radius, and the radius is the outer radius here, and then here's the inner. So then basically, this represents taking the volume of the outside, and finding the outside radius, multiplying by pi, and then subtracting the volume of the inner. So when we do that, we can just plug this in. Remember to multiply by pi, and we do that, we can get this integral pi times the integral from 0.15 to 3.14 of 3 plus ln x squared and then minus 1 plus x squared dx. And when we do that, we get 34.199. So this is equal to 34.199. And if you think about this, this makes sense, right? If you imagine the visualization of this in your head, it's going to be almost like a bowl without a bottom. There's going to be an outside and an inside, and it's going to be like sliced. So to find the volume of that, you just have to take the outside minus inside, which is what's done here. Outside, inside. So that's part B. So you would get your answer of 34.199. Now part C, write but do not evaluate an integral expression that can be used to find the volume of solid generated when R is rotated about the y-axis. Now this problem is a little bit more difficult. Because we're rotating around the y-axis, we have to write everything in terms of y, right? So we are given equations y equals ln of x and y equals x minus 2. Now writing this in terms of y, the first one, we just raise everything to the e, right? So then we get e to the y equals x. And for the second one, we would have to add 2 to both sides. So we can get y plus 2, equals x. Now, we have to do this because since we're rotating around the y-axis, we have to differentiate in terms of y. So we have to integrate in terms of y, and everything has to be in terms of y, right? So to solve for a volume, we simply have to take the integral of y plus 2, because when we rotate around the y-axis, this line, x equals y plus 2, is on the outside, and x equals e to the y. This line is on the inside. So what we would have to do is x plus 2 squared minus e to the y squared times pi. Again, the squared is in the pi is just because the inner and outer radii, dy, because we're integrated in terms of y. But this times our bounds change as well, because since we changed from dx to dy, we would have to subtract 2 from the top and bottom, because that's what we did to the, so we'd have to subtract 2 from the 3.14 and the 0.115. And this is because we had the equation before y was x minus 2. And previously, our balance were in terms of x. And now they're in terms of y. So we'd have to subtract 2 from both sides, from top and bottom. To get 3.14 minus 2 and 0.15 minus 2. And then this would be the this would be your expression that would represent the volume when rotated around the y-axis. Now, writing this again in a little neater format, this would just be pi times the integral from negative 1.85 to 1.14 of y plus 2 whole squared minus e to the y squared dy. And that is your answer for C. Now, if you're struggling with this problem, there are many similar problems, but what you can do is you can just improve your integration skills and just practice. You can pick your own line, pick your own regions, and just practice on integration, rotation, volume, and you can just pick random lines and just get a better feel to how to do these problems. They're not that hard if you just think about it, and just if you can visualize it and you can find the outer one and the inner one, just remember to square, remember to multiply pi, and then you should be fine. Thanks for watching.